Thank you. My name's Robbie, and today I'm going to be presenting you with this rather sensational title of "It's Not Just a Type Dream, Attain Fearless Velocity with TypeScript." Please forgive any hyperbole that might have existed in that title. So what am I hoping to really achieve by the end of this presentation? Well, we're going to split it up into 4 sections. The first one is going to be more about what TypeScript is and how we can use it. Then we're going to talk about actually getting it to work on your React Native project. And then we'll get further into the integration about how you can actually start to convert your existing JavaScript into TypeScript. And then we'll just end off with a review of some of the alternatives in the static typing world and why I personally believe that TypeScript might be the best solution at the moment. So, just to start off, a little bit about me. I have been using React Native for just about over a year. Prior to that, I've been entirely JavaScript. And I work at Birdie, which is an application built in React Native that looks to facilitate elderly care across the board. So what was our problem at Birdie? And how could TypeScript really help that? Well, luckily enough, we were a startup that was growing. Unfortunately, what came with that was new developers and also a larger code base. And with that came a loss of visibility as things were being added to said code base. Unfortunately, to accompany that, we desperately decided that unit testing wasn't for us at the start. It was very much a sweep it under the rug and we'll do it later philosophy. And yeah, ironically, we demanded continuous deployment, so I don't really understand what we were thinking at that time. And what it meant was that we were in this situation where we desperately wanted to continuously deploy little bits of code and for it to fit perfectly like that. But what we actually got was a systematic shooting of ourselves in the foot on a regular basis over what I think we can describe as pretty silly mistakes. These are type errors. These are null pointer checks. These are things that really should be avoided, especially in modern development with everything we have available to us. So what did we do? Well, I suppose one of the solutions that people think about silly mistakes is, well, just be more cautious. You know, if it's a silly mistake, stop being so silly. Unfortunately, that ignores the fact that you're human and you're going to make mistakes. One of the reasons we use machines in the first place is so that we can not be as human when it comes to being erroneous. The second thing really is create more unit tests. It's an amazing idea. You really should, if you're starting projects from someone that has gone through an experience of not using it to having used it. I can tell you that you will much further be thankful to yourself if you just start using it from the beginning. However, it's not something that's going to happen overnight. Not just in the case of actually getting coverage for your code base with tests, but actually the TDD mindset is something that takes a while to really teach to a development team. Can you start thinking about a test before you actually build a feature? And do you know what to test for? These are things that can take essentially in excess of months if your team is large enough. Also, like I said, these mistakes that we had were quite silly mistakes, things that could have been easily avoided. I would say that if you're writing tests, you don't essentially want to be testing for everything. If you end up writing tests for every silly mistake you make, you're going to end up with a huge, cumbersome piece of code, which will probably detract readers from what it's actually more importantly looking for. So, what can we do next? Well, I guess we could find something that allows teams to more explicitly write code that prevents inattention errors while simultaneously exposing APIs with typed interfaces. But what could that be? Well, obviously, you read the title. It's TypeScript. For anyone that doesn't know what TypeScript is, it's essentially a superset that compiles into JavaScript with the core objective being to apply the concept of static typing to what is a dynamically typed language. Static typing is basically the concept that when you write or define something in your code, you have to define what it is at the time. If you have a variable that's a number, you say it's a number, and like so. So I'm just going to go through a few small examples of how TypeScript works. This is actually from an article on the TypeScript documentation called Learn TypeScript in 5 Minutes. Hopefully I'll achieve it in less. But this is a simple JavaScript function called greeter. It takes an argument called person, which is concatenated against a string called hello. And in this case, we instantiate it with a variable called JUSER, and we render that to the DOM. Now we've converted it to TypeScript. And essentially, the important thing to notice here is that we have specifically defined that the argument needs to be a string. On a very high level, how is this helpful to us? Well, essentially, what if this code was split across your entire code base, and someone didn't really understand what the function did, and they passed it an array, or they passed it an object. These are things that obviously would have erroneous circumstances and consequences for your product. Very simply, with about 5 letters, we've been able to prevent this from happening by quite simply defining that you must put a string in there. And what does that look like to the developer? Well, you can quite simply take out, you can replace what it is, and TypeScript itself will throw an error. So here you see I'm replacing JUSER with a number, and TypeScript saying, nah, it's got to be a string. Let's go a little bit deeper. So now people who are used to using statically typed languages, so Java or C#, will probably be used to this structure here at the top, an interface. For the sake of simplicity, I'm just going to define an interface as a structure that is used for mapping types to object properties. And that's exactly what it's doing here, really. In this example, we've replaced our string with a person, and we say, hello is concatenated next to a first name, an empty space, and a last name. And we provide it the same as so. And in the IDE, it looks pretty much the same. You remove last name from user, TypeScript kicks up a fuss, and it says, I don't want just an object with first name, I want something that matches person. Last but not least, the class. Obviously, this is a React Native talk, so we need to discuss classes as they are one of the simplest building blocks of components. In this case, we have kept our interface person, and we're still checking our argument against it. The only difference here is that user is now an instantiation of a class that is created from a first name, middle initial, and last name. And when we pass it to this function, the important thing to notice here is that it doesn't actually mind that this class has an extra property, middle initial. What it minds is that it has what the interface requires, a first name and a last name. And here you see we basically remove last name, and both the instantiation and the function themselves decide to throw an error. So hopefully you've seen some value in that, but just to describe it in some further detail, how did this really help us at Birdie? Well, if you remember what I was saying, the main problem was that we were trying to continuously deploy, but we weren't realistically checking for small errors, no more than just having a human observe it in code review. And what hopefully the last few slides have shown to you is that you have this ability to detect errors exceptionally fast. And where does that add value to you or your business? Well, if you take the example that we just showed, you have someone that perhaps provided the wrong argument to a class or a function. Now, they've basically done that. TypeScript has thrown an error, and within about 30 seconds or so, they've kind of been identified it and they've remedied it. What's the alternative? Well, the worst case scenario, which has happened, and I have seen it happen, is it passes code review. You deploy it, it passes code review, it gets deployed, and eventually down the line, someone realizes what it is, and then it gets highlighted to you, and then you basically have to make the changes, and you've wasted the time from all it took to deploy it, all the way up until how long it took you to remedy that. Now, if you're a startup, you understand that time is a necessity, and you don't really have the luxury of making these silly mistakes on a day-to-day basis. To sort of accompany that, the real perk that I love about TypeScript as well is that you are essentially writing, or rather exposing an API for your code as you write it. You're saying, this is what this is what it takes, this is what it returns. And it means that anyone that new, especially if you're part of a growing company, has the ability to understand at a much more accelerated rate what is actually happening in your code base. So let's move on to the installation side. The first thing you really need to think about when you're installing TypeScript, to be honest, is what tools you're going to use and mainly what IDE you're going to use. Not all of them are equal, and especially in the scenario of TypeScript, some are more useful to you than others. So obviously, I myself have been using WebStorm for the last 3 months. I think it's an exceptional IDE. Obviously, TypeScript talks, so it comes with native TypeScript support. It has some of the most fantastical auto-completion and refactoring available. You can change the name of something in a file and you don't have to worry about your imports and your references in other files. It saves you tons of time by basically dealing with it for you. Unfortunately, there's no such thing as a free lunch, and some of this functionality will cost you a penny or two, but I'm sure if you smile hard enough at your CTOs, you can perhaps express the value behind a tool like this. Then you've got Atom. Atom is kind of what I used before, not really an IDE, but it has released its own IDE plugin. Very extensible, and because of that, it doesn't actually come with TypeScript natively, but you yourself can make it a tool that works for TypeScript. Unfortunately, the performance is actually terrible. I don't know if anyone's used it, but if you have more than about 10 plugins, it sounds like your laptop's starting its own space program. So you've got to be a bit careful with that one. Visual Code, I think this is going to be the big winner of anyone. Made by native TypeScript support. Obviously, that would be a bit awkward if it didn't, seeing as it's been made by Microsoft. It's fast and lightweight, and the auto-completion in CodeCheck, whilst not good as WebStorm, is still pretty damn good. So you're probably going to have to forgive some of the hyperbolic imagery that I've decided to use here. It is not exactly the dichotomy between heaven and hell when we're talking about installing TypeScript on React Native, but I wanted to get a point across quickly, so please forgive me for that. Basically, the version that you decide to install it on will make a difference. For the sake of this talk, I am going to go down the hell path, mainly because it covers pretty much all of the steps of the good path, just with a few added ones. And so essentially by doing that, I'm covering the good path as well. So why is it more difficult on React Native 0.56 or lower? Well, essentially, React Native obviously depends on the Metro bundler to take all of your JavaScript files and bundle them all up together. Now, unfortunately, Metro is incapable of understanding what TypeScript files are, or more specifically, how you can compile them into JavaScript to be bundled. And so in this case, what we need is a module called React-Native-Typescript-Transformer, whose job it is to basically do that for Metro and allow it to continuously bundle TypeScript files in your codebase. Why don't we need that in 0.57 or higher? Well, some people may or may not know this functionality now comes with Babel 7, and so it basically handles the compilation of TypeScript as it itself is performing this job. However, it's a bit of a false flag because whilst it does actually compile the JavaScript, it's actually not doing any type checks on your files. So it's essentially just taking all of the hard work that you may have done with your TypeScript and saying, I don't care, I'm just going to turn it into JavaScript and see what happens. So in this case, you'll either A, want to continue to use the TypeScript compiler, or B, have enough confidence in your IDE's linter to basically hope that you'll catch everything at that stage. So let's go through the installation steps. First one, like I mentioned, is you're going to need this React Native TypeScript transformer so that you can effectively bundle your TypeScript files together. Pretty simple. I'm sure most people here know how to install a dependency. You can either use yarn or npm. Then you've got step 2, which is we need to configure React Native with a custom configuration to say, look, I know you're doing a great job bundling all those JavaScript files, but can you actually take notice of some of these TypeScript files and run TypeScript-Transformer on them? And that's pretty simple. You just create a file, which is a React Native CLI config file, and you just give it these 2 properties. So if we start at the bottom one, we see get these files, these sort of files, these TypeScript files. You've got TS, so TypeScript, and your TSX when you actually want to render some things as well. And then we're just saying you take those kind of files and you run this module over them. Step 3. So you've effectively got React Native to start playing ball with TypeScript. But now you actually need to make TypeScript really work the way you want it to on your project. And the way you do that is with a file called tsconfig. Now, there are a lot of different configurations that you can do for this file. So I won't go into all of them, or else we'll be here till tomorrow. But there are a few that I think perhaps give you a bit of a flavor about what it's capable of and what you can do with it. So the first is the target. This is basically you saying, TypeScript, I would like my TypeScript files to be compiled into this. The second one is the strict null checks. This one and the next one are 2 very important rules that I think you should involve in your TypeScript projects. The first one is strict null checks, which basically makes sure that you cannot access the property of anything that has been defined as null at one point or another. You may be thinking, that sounds really annoying because what if it's not null anymore? All it's really saying is you have to explicitly define in that context that it is no longer null. For example, you provide an if statement that just says, if X is not null, and then within that, TypeScript will understand that the context is that it's no longer null, and you can start to access properties inside of it. No implicit any, possibly the most important rule that I think you should take notice of when you start a TypeScript project. This basically says that everything needs to be typed. Basically, everything needs to be typed to one extent or another. And what essentially that forces you to do is you have to fully embrace TypeScript in your code base. For example, you have a full JavaScript project, and the moment that you start to create TypeScript files from that, and this rule is true, it's going to flare up a bunch of red, but at that point at least it will give you the initiative to actually get started in this transformation process. The only problem is, if you don't turn this to true and you leave it as false, you can basically turn all your files to TypeScript and nothing's going to be sort of kicked up as an error because you're implicitly saying that everything can be an any. And more or less, I think it kind of encourages a bit of laziness in the whole process because you can kind of get away with doing nothing. So you've now got TypeScript working for React Native, and you've told TypeScript how you want it to work on your project. And now you just need to start the packager with this new configuration, which you would do by running React Native start and just doing the path to your configuration file after the config option. Last but not least, so everything is now working for you on your project. Unfortunately, this being the world of JavaScript, you probably have an ocean of dependencies that need types as well. And luckily, it's not that difficult. TypeScript is a pretty well-embraced library, and everyone, basically, a lot of the people use it. And therefore, it's quite easy to make sure that you can get types for all of your dependencies with relatively minimal effort for yourself. So in this case, as you can see, the syntax for installing types to your project is pretty simple. You just do it like you would do anything else, but you prefix the name of your library with @types /. And once you've done that, it's relatively simple as to how you implement it in your projects. You can basically import the types as you would import any sort of a submodule from anything like a library like React Native. And you can start to use it. So here we've got app state status, which basically tells you if your app is active, inactive, it's running in the background. And I think a good example of where this would be valuable to you is obviously this type here would be an enum, and it would say what sort of strings are applicable to this type. And let's say one of the big perils of having a string in any sort of condition is that it leaves room for spelling mistakes. Let's say someone accidentally misspelt this. Since it's being now checked up against this enum that you've imported from React Native, this error would actually be caught a lot quicker and save you some time. Unfortunately, it's not a perfect world, and sometimes you need to just get your hands dirty and make your own type declarations for your libraries yourself. It's relatively simple. As you can see here, we just declare the module with the name of the module, and then inside it we define everything underneath that is involved within that module. Whilst this may seem slightly tedious, if you're good enough at Google, I guarantee you can find someone who's probably done this for you, and it's floating around on Stack Overflow. So don't worry too much. And like I say, you basically declare the module, and once you give it this extension .ts, the D standing for declaration, you can basically, it's now open for TypeScript to find. So, brilliant. You have officially got React Native, sorry, why do I keep saying that? TypeScript working on your React Native project. You have an understanding of what TypeScript is, and you can now start to actually implement it within your project. So here I have a component in JavaScript that's called hello, and what it essentially does is it renders a line of text from which your name that is gathered from some props that is passed into this component is rendered, and then there is a number of exclamation marks that is directly related to a piece of state called enthusiasm level, and then there are two buttons underneath it which are responsible for changing that state, and that then changes the number of exclamation marks after your name. If that wasn't clear enough, here it is. So as you can see, we've got my name, which is passed by props. We've got a default number of exclamation marks, which is also passed by props, but these buttons essentially change one piece of state for the component, and that changes the number of exclamation marks. So now we have converted it to TypeScript, and there's really two things that I think are of importance here. We see two interface structures like we covered at the start of the presentation, and then a slightly interesting structure just next to the extension of the component, which I'll cover in just a bit. But first, let's look at the interface. Like I said earlier, for the sake of simplicity, we're defining an interface as a structure that we use to effectively map types to object properties. And that's exactly what it's doing here, really. We're just saying that the props consist of a name, which is a string, an enthusiasm level, which is a number. And you may be thinking, what's that question mark doing there? That is essentially just a way that you tell TypeScript that this is an optional property. It doesn't need to be provided, but if it is provided, it needs to be a number. And then underneath that, you can see the state, which is same as it is in the props. It's just a number. What probably scratches a few more heads is this strange structure at the end of the React component. Like I said earlier, for people that may have come from other static type languages, such as Java or C#, you may understand this. But what it essentially is something called generics. And it's used for the case where we do not know what a type is. At the compilation time, when we are running something. However, we don't know when it's defined, but when we actually start to compile the code, we want TypeScript to be aware of what that type is. And it's actually a relatively complex subject in TypeScript. I think it's probably one of the more complex structures that you get in TypeScript. However, how does it really apply to us? Well, like I said, it was being used after the component that was created in React. And why would React basically not have a strong idea what types being passed into it are, but would need to know about it at the point of instantiation? Well, it would be set state. It's exceptionally important that the component is aware of what the state is when it actually gets instantiated. And what that means is that when I try to set the state, and I set it as something that the type that I provided in that generic wasn't. In this case, I say enthusiasm level. I'm trying to change it as a string, but I've defined it as a number within the state that I passed to the component. It kicks up an error. And this basically gives us a far better handling of type control within the component context. So we've covered really how to integrate it. I think with what I've shown now, you can get a pretty good start with how to actually start changing your files over to JavaScript and move them over to TypeScript. Now, let's just cover some of the alternatives. I think one thing that people, when they first hear about static typing, but they're not used to it, and they work on a React project, they might say, well, why can't I just use prop types? It's essentially static typing. Hopefully, this presentation that I've given so far, most people will see why that's not the case. But let's define it a little bit further, just to be a bit clearer. So it is so much more than prop validation. Like I showed, you have this really strong IDE support. Prop types is quite heavily confined to the context of the file that you're working with, whereas when you use TypeScript, it's aware of everything that is being imported and typed in your code base. To go along with that, you also have the navigation features. You can quite easily navigate around your code by the types that are being imported and defined. Also, like I just showed with the generics, TypeScript is capable of so much more than just sort of quite solidly and linearly defining what type something is. It has the ability to basically work with things that might be a slightly more dynamic than what we're expecting at the time. And obviously, the big one is that prop validation, it's in the name. It's very much just for a very specific part of your code base. And there might be huge parts of your code base that are left untyped, whether you use Redux or you have middlewares, or even just a utility file. So the better question here is probably, what about Flow? And can I just get a quick show of hands? Has anyone here used Flow before? OK. There's quite a lot of people that might beat me up in the car park for having a dig at it. But no, to be completely honest, our project, we used TypeScript initially because we had 2 people in the team that knew it better, and we needed a quick turnaround time. I myself have not used Flow professionally. I've used it for a personal project, but I am definitely not an expert on it. That in mind, I have a few opinions about why I think TypeScript is the better choice, and I'm happy to be challenged on any of them. So there is the larger community. TypeScript has been around for a lot longer, and as far as I can tell, the discourse, the volume of discourse on it is far greater as well. If we look at the state of JS, which is basically a survey conducted every year of about 20,000 developers across the world, we can see the sort of differencing in opinions of developers between TypeScript and Flow. Flow seems to have sort of plateaued over the years and is not increasing as much as we see for TypeScript, where it has gone from 20.8% to 46.7% of people saying over 2 years that they've used it, and they would use it again, compared to a 10.2%. Then we have the better errors. This is something that I think Flow gets a relatively large amount of critique for, that essentially some of the errors can be a little bit too verbose. I myself, obviously, having only used it in a personal project, have not seen this much, but I did decide to sort of try it out for myself by going to the relative playgrounds of both supersets. So this is TypeScript's one. You just define a title, and you set a string, and I give it a number. It's pretty simple. It just says it's not assignable to a string. On Flow, you got a bit more of a lengthy answer. It says the same thing, sort of, I mean, technically 3 times, but there's a lot of stuff here that I think to an initial person who's getting used to the concept of static typing might seem slightly intimidating. And the assumption I sort of make from this as well is that as the types become more complex, so do the errors that are returned with them. And so some of the verbosity that you can see demonstrated here might actually get worse in other scenarios. And then there's just the IDE integration. So there's the fact that there are a lot of IDEs that do sort of go for a native TypeScript approach. But there's also just the volume currently at the moment of IDEs that say that they support one superset over the other. So these are all the ones that TypeScript say they support. I think we've got about 11 or so there. And compare this to the number that Flow support, it's far less. And this may be to do with perhaps its infancy compared to TypeScript, or it could be perhaps a reflection of the general mood in the developer community about what they would rather use. So I'm just going to end with this. I do realize it's slightly controversial to bring Airbnb up in a React Native meetup. However, I do think this is an important point. This is from a talk that Airbnb gave about 2 or 3 weeks ago. I'm still trying to find the video. If someone does find it, I would love if you could send that to me. But if we take it at its word, it was a talk that they gave where they ran an investigation into their own code base and how much time, how much effort, really, how much quality and value had TypeScript added to their project. What they essentially highlighted was that 38% of the errors that were made in their code base could have been avoided by TypeScript. And I guess we sort of have to ask ourselves if Airbnb, which is a company that quite literally has made their own style guide, which is widely accepted on JavaScript, can be susceptible to these kinds of errors. Are we ourselves so immune from them? I myself would probably say not. Thank you very much. I know it's a bit long, but thanks for listening, and I will try my best to answer any questions. Yeah, it's an interesting. So the question there was that I mentioned at the start that unit testing was a solution to the problems we had, and if we involve typing, do we need less unit tests? So I think the 2 points that I thought were important were the first one, that typing is often there to reduce silly mistakes. And for me, a unit test should really be focusing on user paths that you don't want to sort of clutter with every single scenario that can go wrong. And so if you don't have typing and you do completely rely on the concept of testing for it, what I think you end up with, and it's not necessarily always the case, it is a very cumbersome file, which is basically trying to make silly tests for silly mistakes. And when you don't have that and you have the typing in place, it basically means that you can focus on testing what is really important to your product and what is important to your users. That is an amazing question. And I do not have the answer to it. I would be surprised if there wasn't. I do know that Facebook themselves, who are responsible for creating Flow, are starting to move some of their projects over to TypeScript. I think Jest itself is moving over to TypeScript. So I'd be surprised if we didn't see these kind of tools being introduced soon-ish. It's a very iffy statement I just made, but yeah. Yes, so the main benefit, disadvantage, it's the learning curve. For someone, like I said myself, who spent the entirety of their career working with JavaScript and sort of being a champion of dynamic typing, when this concept gets introduced to you, it slows you down, definitely, at the start. I'd be surprised if anyone said that it didn't slow them down, getting used to the concept of dynamic typing. How did we overcome it? We had 2 people in the team that knew how to use it. But really, it's just practice makes perfect. And honestly, read the documentation that they have. It's amazing. And just use it and play around with it. I wish I could give you a better answer than that. Yeah, so like I mentioned earlier, you can basically have this no implicit any rule, which basically means that you have to define anything. The sneaky thing you can do, as you just mentioned, is that you can just give explicitly the type of any, and therefore you're sort of technically writing TypeScript. But you're not. How do we pass that? Really, the best thing is that it's a bit of a faux pas in our code reviews, and it sticks out like a sore thumb. So if somebody does put an any, they're normally going to have a pretty good excuse as to why they're doing it. Yeah, so that was how does it affect your productivity, and does it make it faster? So as I mentioned, initially there is a learning curve. You will code slower. I'm pretty sure you will. unless you're some sort of TypeScript savant, you're probably going to code a little bit slower. However, the important thing I really think here is understanding the difference between short time and long time. You will lose some of the short time. Your turnaround for creating features will be a bit slower. However, if you start to notice bugs a lot earlier and imperfections in your code, the time that you'll actually gain from not having a project manager tapping you on the shoulder saying it's not working will actually benefit you a lot more in the long run. And it's more of a strategic play than a tactical one. So that was, are we measuring the actual sort of productivity gain that we're gaining from TypeScript? The real answer is no, we're not. We're not directly measuring it. However, what we do measure is the number of bugs that we have. So it's not so much a speed and time saved metric as it is the number of bugs that are actually being returned. And there definitely is a positive trend on that one. Yeah. Yes, completely.